This is Algebra 2 with Trig. We're working on 3A.2a. We're going to graph rational functions. A rational function has the form of y equals p of x over q of x. So we can have a rational function on top, or we can have a polynomial on top. We could have a polynomial on bottom of the fraction, the numerator and the denominator. So our inverse function is 1 over x, and that would be considered a rational function. So we're going to talk about what the graph of 1 over x looks like. So if we have y equals 1 over x, this is going to be a rational function which consists of two symmetric halves called branches. Notice here on the graph we have this curve that's in the first quadrant, and we have a curve that's in this third quadrant. When you plug in positive values of x into your equation, you're going to get a positive result. 1 over 1, 1 over 2, 1 over 3 is all positive numbers. If you plug in a negative x value, 1 over a negative is always going to give you a negative answer. Notice that when x gets bigger, 1 over x, so 1 over 1, or 1 over 4, 1 over 10, 1 over 100, that number, that value is getting smaller and smaller. 1 over 1,000, it's never reaching 0. 1 over any number can never reach 0. So we call that line that it can never reach, we call that line an asymptote. An asymptote is a line that your graph will never reach. And you also can never plug in an x value of 0. So there is a horizontal asymptote and a vertical asymptote. There is an x value that cannot be used in the calculations, and there is a y value that can never be accomplished in the calculations. The domain and the range are all non-zero real numbers. So if you look here, we have a domain where the x values are negative all the way up, but not including 0. We cannot use 0 because 0 makes this undefined. 1 over 0 is undefined. And then we use 1, 2, 3, or 4, and those would give us possible values that we can plot. The same thing is true for the range. We can get y answers all the way up to 0 and anything past that, but we can never get the answer of 0 out of the equation 1 over x. So any function in this form of a over x has the same asymptote, same domain and range as this basic graph does of 1 over x. So we're going to come down to graph this, and now we're going to graph y equals 4 over x. So 4 over x is in the same format as 1 over x. So it's going to have the same asymptotes. You have x values, can be any x value except 0. You cannot take 4 divided by 0. So we're going to have a vertical asymptote at x equals 0, and you want to label that as x equals 0. And then the type of answers that you can get. You can get positive numbers by plugging in positive x values. You can get negative answers by plugging in negative x values. But you can never get the number 0. There is no x value that this would calculate to be 0. So that is considered an asymptote. The graph is going to approach that. You can get pretty close to it, but you can never reach it. So when we make a table, we're going to be looking at our vertical asymptote, which is 0. And you're going to pick values to the left of that, and you're going to pick values to the right of that. What's best to use are numbers that go into 4. If you pay attention to what type of your equation you're working with, use numbers that would divide into 4 nicely. So 1 would divide into 4. 2 would divide into 4. 3 not so it wouldn't go in there evenly, not so easily. So we could easily do 4. 4 goes into 4. 1 goes into 4. 4 divided by 1 is 4. 4 divided by 2 is 2. 4 divided by 4 is 1. So we can plot those points. When x is 1, our y value is 4. When x is 2, our y value is 2. X is 4, our y value is 1. We could plot that out. Now we can look at what happens to the left side of the asymptote. So -1, -2, probably use -4. So 4 divided by -1, you got to do some calculations here. 4 divided by -1 is -4, -2, and -1. So you plot your points. And you draw your graph. Notice what's happening. The graph is approaching the x-axis. The larger the number is in the denominator, the smaller the total value is. So 4 over 8 would be 1/2. 4 over 16 would be 1/4. 4 over 400 would be 1 over 100. 1/100th. So it would get closer and closer to 0, but it would never hit 0. Same thing here. If you put in a negative, you're just getting closer to 0 from a negative point of view. So your vertical asymptote is x equals 0. Your horizontal asymptote is y equals 0. So when we talk about the domain in the range, you see that it's going to be all the numbers. You can pick any x value you want. You just can't calculate a 0. So it's all real numbers, comma, except x equals 0. That would be your domain. You can hit any number, you can use any number, except x equals 0. The range. Look at what values we get in our y for the table. You can get any number except, noticing on the graph, it never touches the x-axis. It never touches where y is 0. The type of comparison that's going on, there is a vertical stretch by a scale factor of 4 between the 1 over x and the 4 over x. The only difference is that you're multiplying each of the original graph by 4. All the y values by 4. Now we're going to translate these graphs. So notice that the format for translating has an H and a K like we have done all year, where the H is going to move it right and left, and the K is going to move it up or down. What we're going to do is draw the asymptotes. And the asymptotes are going to be where the H value is. It's always opposite the sign. And you're going to have a horizontal asymptote at the K value. So you have a vertical asymptote and a horizontal asymptote. You're going to plot 3 points to the right and 3 points to the left of your vertical asymptote. That's going to give us 2 branches to draw. And this forms a hyperbola. So the 2 branches of the hyperbola, so that it passes through the plotted points and approaches the asymptotes. So that's our plan for graphing these out. So this graph here is going to look very much like negative 3 over x. You could consider that its parent function, or you could even do 3 over x, and then it has a reflection over the x-axis, and then it has a translation. But what we're going to look at is our h value. We see we have an h value of 1. So that means our vertical asymptote is going to be x equals 1. It's going to translate 1 unit to the right because it says x minus 1. It says that the k value is 2. That means the whole graph is going to be translated. This parent function is going to be translated up 2. So we're going to have a horizontal asymptote at y equals positive 2. So we want to put that on a graph. We can put that in our little chart over here. So you have a good idea what your domain and range are going to be already. All real numbers except x is 1, and all real numbers except y is 2. We'll come back to that. So your vertical asymptote is 1, and we need to come up with calculations that are going to work in here. It might take some calculations off to the side. Notice we are not using a calculator. You can handle some of these. If you got to write them out, that's fine. You're going to pick numbers to the right of your vertical asymptote. Any numbers will do to the right. You have room. This would be 2, 3, 4, 5, 6. You can go all the way up to 6. Okay, you can get strategic on what numbers that you choose, or you can just go right in order. 2, 3, and 4. So we look here, when we plug in a 2 for this, we get negative 3 over 2 minus 1. So that's negative 3 over 1. That's a total of negative 3. Plus 2 gives you negative 1. When you plug in a 3 for this, you would have negative 3. 3 minus 1 is 2. So you're going to have this. You could convert it to a decimal if you thought that was going to be helpful. I like to keep it as a fraction, and we're adding 2 to it. So the fraction that represents 2 with the denominator of 2 would have to be 4 over 2. So you have negative 3 over 2 plus 4 over 2, which gives you 1/2. That can be a little tricky. And then when we plug in 4, we have negative 3. 4 minus 1 is 3. Well, that's a value of negative 1. Negative 1 plus 2 is 1. So we've come up with our table. We can plot those points. When x is 2, we're at negative 1. When x is 3, we're at a half. And when x is 4, we're up here at 1. And notice that's curving right along, heading towards each asymptote. Now we're going to look at the values to the left. You can be strategic about which ones that you cover. So we're going to pick numbers to the left of the vertical asymptote. That can be 0, negative 1, negative 2. Doesn't really matter which ones you do. You have plenty of room to choose any of those values. So we are taking this x value and we're plugging it into our equation. Negative 3 over 0 minus 1. So that gives us negative 3 over negative 1, which is just 3. Plus 2 more gives us 5. So we plugged in 0 and we came up with a y value of 5. We plug in a negative 1. It gets a little complicated here. When you plug in negative 1, that gives you a negative 2 on bottom, which 2 negatives become a positive, and you're going to add 2 more, so you need that with a common denominator. That's 7 halves, which is 3.5. And then when we do the negative 2, we have negative 2 minus 1. That is negative 3 on bottom. That's a value of 1 plus 2 more is a value of 3. So doing your calculations is going to make this much more easier to figure out your table. So we can plot out those points. 0, 5, negative 1, 3.5, and negative 2, 3. Notice I did not cross the asymptote. If you come up with a number that crosses the asymptote, you know something's going on. Something's incorrect. So my domain is all real numbers except my asymptote, which is x equals 1. And my range is all real numbers except y equals 2. Do you know where to look at your graph to see that? We're looking at all the x values that can exist. Everything can exist up to that 1. And anything past the 1 can exist. That's why it's all real numbers except 1. And all the y values except 2. We are translated 1 to the right and 2 up. We would also say that there is a reflection over the x-axis because of the negative. Do you see how this is in a different pattern than some of our other graphs? Our other graphs have been in the first quadrant and the third quadrant. This is now in the opposite quadrants because of the negative on the 3. Reflection over the x-axis. Those are your 2 different transformations that are happening to this graph. You could make an argument, I guess, that there's also a vertical stretch of 3. So there's your third one. Vertical stretch of 3. Okay, the last one here. We have our equation. The most basic parent function, we could have said it earlier as 1 over x. Typically, we would consider 8 over x as our parent function, but 1 over x would be totally fine. In terms of our transformations, there is no h value, so there is no moving right and left. It's just 3 units down. So y equals negative 3. So our vertical asymptote is at x equals 0. Our horizontal asymptote is at negative 3. We should label in our x equals 0 onto our graph. So we're going to put 0 into our table, and we're going to want to pick numbers to the right that go into 8 nicely. Like 1 goes into 8, 2 goes into 8, and 4 goes into 8. Those would be nice numbers to use that go into 8. 1 goes into 8 8 times, minus 3 more, which is 5. 2 goes into 8 4 times, minus 3 is 1, and 4 goes into that 2 times, minus 3 is negative 1. So we can plot those points. When x is 1, we're way up at 5. When x is 2, we're at 1. And when we're out at 4, we're at negative 1. Notice that we're dropping down and curving towards our asymptotes. Then we can pick numbers to the left. Doesn't matter which numbers, probably numbers that go into 8 nicely, like negative 1, negative 2, and negative 4. Negative 1 goes in there, negative 8, minus 3 more. Negative 4, minus 3 more. And negative 2, minus 3 more. When you plug in negative 4, it goes in there negative 2 times, minus 3 more. So at negative 1, we're kind of off the chart. At negative 2, 1, 2, 3, 4, 5, 6, we're barely off the chart. And at negative 4, we're back on the chart. Just kind of nips aside. We should always write our equation. Y equals 8 over x minus 3. And on this higher one up here, we should write y equals negative 3, x minus 1 plus 2. Our domain is all real numbers, except x equals 0, and our range was all real numbers, except y equals negative 3.